Good day. My name is Taryn Dale, and thank you for joining me and having the opportunity to review my project assignment. Let me just quickly share my screen with you. One moment. And thank you. So my project, I'll just dive right in, is about building a predictive model for debt buyers and hedge fund managers using the CRISP-DM approach. So our agenda, we're looking at the introduction and the opportunity evaluation, um, introducing the problem, and the opportunity for a predictive model, and explaining exactly why it's a great opportunity. Then we'll look at the CRISP-DM business understanding, explaining out the CRISP-DM framework, and the particular framework I've used, and giving you a breakdown there. Then we'll look at the solution and validation plan that have developed for this particular project, including the prototype and feedback and pilot deployment. And then we'll look at the ML system design, describing the end-to-end machine learning system for data ingestion, feature engineering, model training, and deployment, as I said. And then we'll look at the potential risk and mitigating those risks that may come up, and you'll see uh, the potential risk that will be involved and the mitigation that solution that we have for that risk. And then finally, we'll look at um, the conclusion itself. So, folks, just imagine we're a world where their debt buyers no longer have to rely on a gut feeling or simply heuristics to assess whether a debt portfolio is worth buying. So instead, they can use a data-driven machine learning approach to forecast how much they can recover even before making a bid on and acquiring a particular portfolios. Most of these portfolios are basically in a bid process based on points, X amount of cents on the dollar. Um, and our project aims to build a machine learning model that predicts the recovery percentage of the debt portfolio that someone's looking to acquire, ensuring that the buyer's target portfolio with at least a 30% net recovery rate after all expenses. And I actually chose that amount. Most portfolio debt buyers they are okay with 10, 15%. The liquidation rate is really the key, but there's other factors that come into play in order to truly evaluate the liquidation rate. And that's the process of the individual that is um, not even acquiring that. That's the process of the individual speaking with the consumers and getting them to actually make that payment of that debt. So that also is another factor of it. So that's why I actually boosted up to 30%. The current standard rate, recovery rate, is anywhere from 10 to 20%. This is critical. It's a critical need because a smaller estimation can lead to a significant financial loss, um, or missed opportunity in a whole. So why is this attractive for opportunity for machine learning? So there's three key things here: data availability, complex patterns, and high business impact. So I'll just quickly go over all three. Uh, we have access to a rich core creditor data, historical performance, amounts owed, detailed personal information. This data can be enriched with external sources, and you'll see that as we go through the presentation, what different sources that we can use, such as the credit bureau records, public records, and even social media signals, which we ethically be able to use and legally with the system. Complex patterns, and this is what I touched upon just before. Recovery rates aren't determined by a single factor. They depend on a blend of borrower demographics, specific debt details, external economic indicators, and machine learning excels in uncovering these subtle nonlinear relationships, and that's key. That's why it makes it an exceptional project for this. That traditional methods often miss altogether. So in regards to the third, is high business impact. With an accurate predictive model, debt buyers can avoid portfolios that are overpriced, or unlikely to yield sufficient returns. This not only reduces risk, but also improves profitability, showing that every purchase has a solid basis for at least a 30% net recovery. Now, in this space, during the COVID situation, a lot of these portfolios were off the market and are just starting to come back on the market even now. Um, and the prices were exuberant. The prices for to acquire these portfolios were very expensive, and those were able to afford or acquire those portfolios in the industry paid uh, really high rates, and they barely broke even or they lost money. So even now, this would be extremely helpful to be a build up right now. This particular system. So we're gonna dive into the Christian business understanding overview, and as you can see, this is what we're going through the business understanding, and we're gonna touch upon the first box that's here is business understanding. Well, the other boxes you see is data understanding, and you can see the back and forth that goes through the process as we gather information, speaking with the customer, getting feedback, and so forth, and even preparing the data and building out the model. And eventually evaluation, which can lead back to the business understanding, making sure and the deployment of the model as we go. So we're just going to dive into it and go a little bit further into it. So defining the problem. So the our primary users, I was saying, are debt buyers or hedge fund managers, or those who are in the industry, whether individuals, analysts, or entire teams who need reliable data-driven insights to make informed portfolio purchases. Um, they use a selection process for looking at the pricing of the portfolio and other aspects. Um, and it's very highly competitive market just to acquire these particular profiles, and as I said, and the pricing and everything else. The problem statement: currently, debt purchasing decisions are rely on a manual reviews, simple heuristics, or limited data analysis. And from my experience, I can tell you up front, this is very, very accurate, which is the heuristics in itself is heavily relied upon, which sometimes is not as accurate. I have seen where looking in an analysis of portfolios, they just look at past history, and in this particular industry, as I said, with COVID, which was an anomaly that showed up, it really put things through a monkey wrench in, in evaluating portfolios. So they heavily rely on that. So that is something that that gut instinct is usually not 100% accurate at most of the times. So why does it matter? The financial implications are enormous. Don't uh, portfolio that doesn't achieve at least 30% net recovery after expenses can lead to significant losses. In contrast, a well-priced portfolio not only safeguards investment, but also gives the buyers a competitive edge in the market. So if someone had this and then uh, a portfolio manager, a hedge fund manager, or a debt buyer had a system like this, there's some things out there are similar, but there's a scoring model. Um, it'd be extremely advantageous for them to be able to evaluate the portfolio itself in a whole before making a buying decision. So the current methods we touched upon today, many buyers use a rule of thumb or a sample subset of accounts manually. These methods are subjective, fail to capture the complexity of the borrower behavior, which is key. And machine learning it can definitely capture this, and external economic conditions, and are not scalable to large portfolios that can contain tens of thousands or even millions of individual records. So that's the problem that we're probably seeing. So part of the constraints as well, you must handle sensitive personal data like social security numbers, addresses, with strict in accordance with the FCR and the GDPR. Addition, one of the things that I've seen is not all creditors offer high quality, consistent historical data, which can complicate the modeling itself. And that's a big issue. And finally, our solution must deliver actionable insights in a timely fashion. Weekly updates should suffice for a strategic decision making for someone looking to acquire a portfolio. So we're going to move on to next. Defining success. Um, the expected business impact. The core goal, as I said, is to enable debt buyers to reduce poor purchasing decisions By accurately predicting net recovery rates, the model will help buyers consistently secure portfolios that yield a net recovery rate of at least 30%. This translates directly into a better return on investment and fewer bad buys. Now, the outcome metric. Our main outcome metric is the net recovery rate on acquired portfolios, calculated as the total amount recovered minus collection expenses, or those other expenses of outsourcing and being someone to work those portfolio, work the files, so to speak, divided by the acquisition cost, the cost that you paid for the portfolio. If we contain and exceed a 30% net recovery rate on 80%, our deals or solutions will be considered successful. Now, the output metric. From a technical perspective, the model's predicted recovery percentage should align closely with the actual recovery rate. And I choose here, this is where my choice would be. I would measure this using an error, using RMSE, which is a root mean squared error, and to calibrate the predictions to ensure they are both accurate and reliable. So look at 1.3. Identifying relevant factors. And this is one of the key things why this is perfect for machine learning, and it's important these aspects are put together correctly. So the first one is the borrower's demographics. Um, so these are the factors we're going to use to build our model. So age, marital status, home ownership, employment status, location, state and zip code are all important indicators of borrower's likelihood to repay. The other thing is the debt characteristics. Key details include the type of debt that they have, credit card, medical, student loan, so forth, the amount owed, how long it's been since default, interest rates, and any past collection efforts on top of the debt itself. uh, Enrich data. So this is also very important. This is where you're taking it up to the next level. By integrating additional sources such as credit bureau scores, public records, and even social media data used ethically, which is key, we can capture a fuller picture of the debt each debtor. So we're trying to build the complete aspect, or one can say profile of the debtor themselves. This might include indicators of recent job changes or major life events that can influence repayment behavior. Historical performance. This is one of the key things why machine learning is also important, because the amount of data, high quality data to some aspects, and it all depends where you're getting your purchasing your portfolios, because certain portfolios can be purchased through a third party or directly from the source. So past data on payment patterns and previous recovery outcome provides a baseline for what they expect similar future portfolios. So having that information, be able to feed it and create it into our model, will give us a better predictive outcome. And then last, definitely domain expertise. So insights from the debt buyers themselves, looking at the liquidation rate of the portfolio, the hedge fund manager as well looking at the liquidation rate of the portfolio, and the debt collection professionals, and able to validate, enhance the features, ensuring that we're not overlooking any critical elements or qualitative factors into the model itself. So solution and validation plan. So as I said, the concept, our solution is a predictive model using techniques like uh, the main one I would definitely use are neural networks. And as you probably can understand why, just because the depth of information and complexity of information that is available, um, that would be my approach. That it would be able to estimate the expected recovery rate percentage for each debt account. It's deployed as part of a decision support system where debt buyers can quickly see whether a portfolio is likely to yield the necessary returns before committing a purchase. So how this basically works is that you're reaching out to the broker or the main creditor source. They'll give you a sample of that portfolio for you for evaluation, and then having that information, you'll be able to look at it and use our model to be able to determine, is this a go or a no go? Is a portion of the portfolio or half of the portfolio or certain segments of the portfolio would be available to purchase? You might not have to acquire the entire portfolio. So you're making sure that you're eliminating or you're mitigating as much risk as possible. So that being said, the prototype with historical data, we start by splitting our historical debt portfolio data into training and validation sets. Known recoveries serves as a label to assess model accuracy. So I would split the model into 80-10-10. Um, then obtaining user feedback. The initial predictions are shared with the internal experts and debt buyers. Their feedback is very invaluable, ensuring the model outputs align with the real world experience and what they're seeing and what have they seen in the past. And then and pilot deployment. So we test the model on a small subset of newly acquired portfolios. So test it on certain portfolios and see how it would happen, tracking the actual recovery rates over a period of 3 to 6 months. And as I said, there's other aspects that come into place. Most times when one gets in a portfolio and acquires in a portfolio and you outsource it to a third party source to acquire that portfolio, there's other factors in place. Within the first 7 to 14 days, you probably will have a good indication, depending on the type of debt and other factors, as I said, if that portfolio will perform and you'll be able to recover X amount of dollars or a percentage amount from that portfolio. So having a 3 to 6 months will give us ample enough time. This phase is critical for the understanding of the model and real world applicability. And, and as we go, we will definitely refine it and iterate based on the performance metrics. And as I said, we use RMSE and expect and expert feedback. We continuously update the features and fine tune the hyperparameters and redeploy improved versions of the model. So the system design we would use. So first part, looking at the data collection and ingestion. So the sources of our data. So our primary source of data comes directly from the creditor legacy system containing borrows debt and details. Secondary data harvested from third-party APIs, including credit bureaus, public records, and ethical social media insights. There's so much data available, some free, some you have to actually pay for, and it can be costly at the same time. And as I said before, depending on the source where you're getting from third party, the source will not from third party sources might not be as reliable, and depending on the type of debt that you're acquiring and the stage of that debt and how has that particular portfolio been outsourced to other parties or been resold, it really looks at that plays a part in the model construction as well. And if you're getting directly from the main source, you know you're getting high quality data in itself. Process a robust pipeline updates that daily daily data, ensure that all new or modified records are stored in a centralized database. Um, feature engineering storage, data cleaning, and this is very important. I've gone through the data cleaning process myself so many times, hands-on experience. A lot of data might be missing, so making sure that the values are correct. Derived features such as debt to income ratios or time sensitive default are critical in ensuring quality inputs. Feature stores. Dedicated feature store holds the most recent version of these features. That's important as the model goes about, because we're definitely be testing different models and seeing which features contributed to the predictive outcome, and some features we'll be able to eliminate altogether. So making sure that set up, ensuring consistency between the model training and real-time inference, and model training and deployment. Um, my process would be go weekly, and I'll explain why here. So weekly retraining pipeline. Every Sunday night, the model is retrained using the latest available labels. This includes every newly known recovery outcomes, ensuring our model remains current with market trends. So the market can having market trends and everything else what's going on, and having that trained on a weekly basis by collecting the data and feeding into our system is going to be important. Then we update the model, um, is validated and hold out on the set. And if it meets our accuracy and performance criteria, it's automatically deployed. Um, and model serving. During the week, the deploy model provides near real-time predictions. As I said, it won't be on a daily basis, but on a weekly basis. Debt buyers can input new or updated debt accounts and receive predicted recovery rate that informs their purchasing decisions. So the more data we get, the more things we see, and the different type of data that we see, the better the system will actually learn and provide uh, uh, a different predictive or better, predictive outcomes. Tooling and infrastructure. So the other thing that we're looking at is batch and near real time. So a lot of the heavy lifting of training occurs weekly. Predictions are served on demand. The data pipeline continuously updates and predicts our predictions are made on near real time. So we use batch prediction uploaded and be able to do that better and get a better idea of what's going on. Then monitoring and logging. Every prediction is logged along with actual recovery data, creating a feedback loop that is central to ongoing performance monitoring and audibility. So that's also important in a nutshell in building our system. So why these key factors as we touch upon? So data availability. We have access to rich credit data, external sources, complex patterns. And recovery rates are influenced by multi factors, demographics, depth details, and economic indicators. High business impact, as I said, to 30%, reducing risk, improving profitability by ensuring the portfolio meets 30% net recovery threshold. Tooling infrastructure, as I said, batch near real time predictions, that is a big giant plus. As I said before, near the beginning, a lot of the accounts, they do have certain scoring models. They're not as accurate, and use a rule of thumb heuristics in itself to evaluate the portfolios. So these are the key main four key main factors. Potential risk and mitigation. So risk the data drift. So although weekly retraining helps mitigate gradual changes or sudden economic shifts may require in scheduled training. Continuous monitoring of the model performance is essential to trigger such interventions. So weekly retraining, that's ensure that we adhere to data drifts or concept drifts that might take place. Training serving skews. So ensure that the same data transformations occur during both training and inference is crucial. Synchronize features, store, minimize discrepancies, and maintain model accuracy. So that's also important. Labels and delays. Given that recovery outcomes may take months, and then and in this case, I would say it could take. It depends how fast you get back the information, and it depends on the type of debt. It could take days or weeks to fully materialize. Strategies like partial labels updates can be employed. The weekly retraining will incorporate whatever new labels are available, even if they're interim estimates. So I believe that it could take months, but it also can take days or weeks to perform basically. Latency and infrastructure costs. Weekly retraining minimize computational overhead while still allowing near real-time scoring, striking a balance between responsiveness and resource use. So definitely that's a help. Um, Privacy and regulatory compliance. Handling highly sensitive personal data demands strict adherence to privacy laws such as FCR and GDPR. Role-based access, so only certain people can get access to that data or see that account. Data encryption, regular audits, also part of the place. Part of it, cybersecurity plays a different big role as well, and as a part of the components and solutions in creating the model and overall monitoring of the model and the system itself. So I appreciate taking the time to review my project. As we touched upon on the first stage of the business understanding, some of the data understanding as well. But you can see that this would be an excellent project to build out. And I thank you for taking the time to have to review this project.